In this paper, we present IDD-X, a multi-view dataset captured using front and rear view dashcam videos for ego-relative important object localization and explanation in dense and unstructured traffic. The dataset can be used for understanding the influence of road and traffic conditions on the ego vehicle's driving behavior and for explainable driving decision making in complex traffic scenarios. Our dataset contains 85 hours of dual-view driving videos captured in dense and unstructured traffic. IDD-X provides 697K important object bounding box annotations corresponding to 9K object tracks with 19 unique ego-relative explanation categories and 10 object categories. A single driving scenario can have multiple important objects ranging from 1 to 12. We now highlight some key differences between the existing datasets and IDD-X. Our dataset contains dense traffic scenes with multiple important object annotations per driving event, while the existing datasets capture sparse traffic scenes with at most one important object annotation. Additionally, we provide the object tracking information for these important road entities. IDD-X also captures the heterogeneity in traffic with 10 unique important object categories like speed breaker, auto rickshaw, bus, etc., while existing datasets contain very few such categories. Traffic scenarios in IDD-X are highly unstructured. As a result, a much more diverse and complex set of important object explanations are annotated. For example, multiple two-wheelers in this case are crossing and overtaking the ego vehicle in very close proximity. Please refer to Table 1 in the paper for a detailed comparison of IDD-X with the existing dataset characteristics. Our annotation procedure involves creating important object tracks in front and rear views and assigning an object category and ego-relative explanation tag to each one of them. Please refer to Section 3A for further details. The annotations in our dataset include the ego vehicle's driving behavior, the important road objects track and category information, and their corresponding ego-relative explanations. Some additional annotated driving scenarios are shown. In this situation, the ego vehicle confronts a car and two motorcycles when it deviates from its lane to avoid congestion caused by the truck. While for this case, the ego vehicle slows down because of multiple road entities in the front view and also considers the vehicle in the rear view while applying the brakes cautiously. We now showcase the bird's eye view figures of these explanation categories. They can be broadly divided into two. The first type describes the passive influence on the ego vehicle's driving decision, while the second type describes the ego-relative maneuvering styles of road objects that actively influence the ego vehicle's driving decision. For a detailed description of these explanations, along with their statistical distribution, please refer to Section 3 in Section 3B. We now introduce custom-designed deep networks for the proposed task of multiple important object localization and per object explanation prediction using dashcam videos. We first detect and track all objects in a driving video and then identify which one are important using an class conditioned bidirectional GRU. We also recognize the ego vehicle's driving behavior using the optical flow video modality. Subsequently, we perform explanation prediction using the predicted important object tracks and the extracted video features. The track of interest align operation extracts the per track video features, which is temporally aggregated and concatenated with the spatio-temporally aggregated video features for explanation class prediction. We now showcase the quantitative results of these individual modules. The important object track selector achieves superior performance when the object class is conditioned throughout the temporal range of the bounding box tracks. The ego vehicle's driving behavior recognizer attains superior performance when using the optical flow video frames as input. The important object track explanation module performs best when the per track features and the video features from the behavior recognition backbone are jointly used for the task. This method especially boosts the class-wise average F1 score, where it improves the recognition of the underrepresented tail classes like avoiding an on-road being and cut-in driving explanations. To summarize, we contribute the first ever dual view driving videos dataset with ego relative annotations for multiple important object tracking and explanation prediction. We provide novel explanation categories for heterogeneous road occupants observed in unstructured traffic environments. And finally, we introduce custom designed deep networks for the proposed task. Thanks for watching.